Hello everyone. So today I would like to present about my cooperative education that at IBISC laboratory. So my topic is AI driven web interface for robotic control. Let's start with what is the IBISC laboratory. So IBISC laboratory is a research lab at the University of Italy. So it established at 2006 from the merger of the two labs. It's the RAMI and the LSC. So it's focused on the digital and interdisciplinary research, so especially in field like geomics and complex system. So the goal is to advance both fundamental and apply the research in information and communication technology. So in IBSC, we have four main research teams. For me, I am at in the SIAM or yeah, team in focusing on the signal image and automation. So as my position from working, I am a research assistant that I have from started from January 6 to April 30. So my nature of work, I have to assist in designing and planning as experiment on research. So anyway, in the methodology or also system architecture, I also have to use the software as a tool to data analysis, or make a simulation and visualization, and also develop a test or can be prototypes for the system. And lastly, have to like the report or the technical report to summary that what I have done, and also the academic paper that if we research some kind of knowledge about what we want to know from the localization of here. Actually, if I can go to France to work there, I will go to the payroll sites that for SIA team, SIAM team. Yep. And for now, I have working like remotely, like I have meeting on the Zoom every time that I would like to progressing. Mhm. So let's dive down to our work that I have done. So let's start with the introduction. So the mainly goal is how can we simplify a robotic control while ensuring the seamless and the real-time operation across the different location, like the faraway location. So it have three main contexts as because we would like to build a pedagogical tool or education tool that can be a hand-on learning of bridge theory that with the student that not know about the engineer much but would like to control the robot, would like to control the robotics. And for me, I like to enhance the critical thinking, problem solving, and the skill that I need to improve, and also require the programming. For the software ecosystem, that I have to use all many language that I can do, like Python. I have to use some OpenCV or SDK to know about what we are going to do. And also learn on the multiple OS because to control the robotic, we can use so many OS to control. And also the digital transition can integrate the AI or deep learning or NLP, something like that. And also the promote the sustainability for right now trend. For the objective in each three main contexts, so pedagogical, so I can control a robotic platform like DJI Tailor drone. And from the software ecosystem, I can master on the SDK that for this drone, and I also use the Python and also the web programming to control it. And also the OS abstraction, I can control like use various of OS to do the work like Linux, Ubuntu, or Mac OS or Windows. And also the digital transition, I can integrate the NLP or AI. We can call AI, yeah, AI chatbot like LLM, and also use the cloud base for seamless remotely control the robotics, like causing far away, like cloud, or maybe we can execute the web framework like Next.js, React like this. So the work separate in two phases. The first one is to create the web platform that for setting the command to DJI Tello that I have done it. And the phase two that integrate the AI chatbot for now it can do, but it's not very uh, great performance. It have like a medium performance that can control. So let's know what is the DJI Tello, the drone. So the DJI Tello Live is the mini drone that can use the programmable, the Python on SDK used as a guide like this to send command by programming to control the drone. This is the classical control that if you want to control the drone like the simple way, you just connect it like this and send the command that you want. So let's see the system architecture that what we can do. So is it the client and it's the drone like this? So the client would be in Thailand and the drone would be in France. So we can use the client, send the command to the crowd. The crowd can give the command to the drone. That is the concept. And also in the same way, if we change that client in the France, but Thailand have drone, so exactly we should do it the same. For the software stack, for the client, like user using like web application, we're using the Next.js. For the cloud server, we're using the Google Cloud for hosting with the backend or the fast API. And for the local server that hosting the LLM or the AI chatbot, and also use the rack to retrieve the command that user need. So the local server we run as the um, laboratory in Thailand in our faculty CoC AI lab. Yeah, we hosting that right now. And also the drone that using the mini PC or maybe Raspberry Pi as you want. So the RAG and LLM chatbot. Let's start with the RAG. What is the RAG? RAG. So the RAG is a technique, right? It's a technique that combine the how we can retrieve the method that we would like to reference. Example like we have the data and we would like to retrieve the command that we want. So we keep this to be embedding as and keep it in the vector DB. And after that, when user type a question of something, it will find the similarity of the answer or the references to give it to the user, but it not give it like just the plain of the answer. It will send to the chatbot or large language model LLM to give the readable answer. So the main things of RAG is the embedding, right? We would need to embed the human command to be some of computer command. So I have testing like two model that BGEM3 and Omni LM6V2, and I have designed the equation for testing. Sorry for the mistake. Yeah, like example, like how do I make the drone take off automatic calling? So the answer we need the human need that it take off, right? So let's test that for the two model, what it will give. So the first one is the Omni LM. Yeah, it's quite good, but it have some command that not exactly give what user need. But the BGM3 have the better performance that in the same of testing correction, it give like just the takeoff that might not okay. Maybe because of the correction that too hard or something like that. So the last one is the chatbot. Actually, we can use that so many chatbot. Now they have OpenAI like ChatGPT, Google like Gemini, or maybe Claude for yep Claude, maybe Glock like that. But for the Typhoon is the of the Thailand SCB. Yeah, it gives us free API to using right now. So I will use the Typhoon for the testing right now. So for the demo application, as you can see, so if we send the command like how to make the drone take off, yeah, it might have some error, but it's okay. So I access again, and the LM, the rack will retrieve that what user will need, how to make the drone take off. So the rack will find the way that the similarity of the answer, like take off. So also you may need take off. So the rack will retrieve the takeoff out, and after that rack will send the answer that it get and the question at the same time sent to the chatbot, and the chatbot, like as everyone know, like ChatGPT, it will try to processing that, oh, in for this question and for this answer it will give the better solution, like better readable result like this, like, oh, maybe you need Python code or the drone take off. So yeah, the drone will take off, it will send to the simulation that I using that from drone blocks. So thank you for the drone block that making the simulation that I so I can test the result. So that is all for my work that I have done for the cooperative education right now. So thank you so much.